We're now going to take a look at some IP packet headers, just so you can kind of compare the chart that we've looked at to the actual traffic and kind of see how everything looks in an actual packet capture. So I want you to pay attention to some of the fields that we're going to see. If you like, go back and forth and compare the chart to the packets themselves. But take a look at the versions, the source address, destination address, protocols, checksums, and so forth. So let's go ahead and look at some IP packet headers. Okay, we're going to look at a Wireshark capture that I've already completed. Now, we're not going to be looking at any particular protocol, but as you'll notice, we've got some NetBIOS name resolution stuff going on. We've got some DNS and some TCP. And one thing that I want to point out is in all of these, if something travels over the internet or uses TCP/IP, there will be an internet protocol data in there in the transmission. Of course, we see UDP, we see the layer 2 stuff, layer 3 UDP, and some of the application layer stuff. But what we're concerned about for this demonstration is the internet protocol traffic. So for each different packet capture that you see, there's internet protocol data, and it may be combined with other layer data as well. Let's take a look at the DNS, for example, query. Now we know that's a UDP query, of course, but there is an internet protocol layer to this, and let's look at and see what it says. Let's expand this out a little bit. So we're going to see the version here. We're going to see the header length. Here's our source and destination address fields, our total length, flags if any are set, fragment offset, time to live, which upper level protocol we're going to be sending through IP, and our header checksum, which is correct. Then we have the source and destination addresses, and then we have the upper level protocols as we see in the capture. So all this right here is this IP stuff we want to look at. Now let's go on down a little bit and let's look at some TCP traffic. The IP header for that same TCP traffic is going to be the same. It's going to be pretty much the same. We're going to see the source and destination IP addresses, the version, which is IP version 4, the header length, different fields that we will see include the length field, the identification field. The don't fragment field is set, so we cannot fragment this particular packet, and there's a fragment offset of 0. The protocol in the protocol field is TCP. It's telling us that it is sending TCP data. We have a header checksum, which is coming out as correct. It's checking out, so that header is not going to get dropped. And we have a source and destination addresses in those fields. And then we have the upper level protocol. And if we can look down here a little bit, if we look at number 19, something interesting, a TCP transmission, retransmission, notice that there's nothing in the IP header that indicates that this packet was retransmitted. IP doesn't care, but TCP does care. So if you look down here, you'll see that there's a push and an ACK set in the TCP flags indicating a retransmission. So even though IP has resent a packet, it doesn't know that. Only the upper level protocol that requested it knows that. So IP just sends what it's told to send to the IP address it's told to send it to from a certain IP address. That's all it really cares about. And it will fragment if necessary. That essentially is an IP packet header. I would recommend that you do a Wireshark capture on your own. Maybe just go to an IP address, a web address, for example, and then just take a look at the IP header information so you can kind of see what it looks like firsthand.